Hello. So far I have been talking to you about where 3D printing is used, a little related to electronics and what you call non-organic shaped objects. Now this session I will try to, of course I will make it short because that is not our main area, because very rarely except in technical objects like this mouse and so on, which are actually very difficult to model and not easy to what you call make. This will not be very interesting. Instead, I thought I will talk about some objects like this. You have seen this, I have a water bottle. Now, two types of uses are required for this. Sometimes they all have a regular shape, meaning there is a symmetry, axis of rotation. So, making these is one type of game, and then by definition you will come across, if you can look at my monitor, you will notice that there are a large number of these what you call generic items you see in the house, while all other items what you see have all been made using injection molding. These are these and child's what you call toys and several of the other things are all made with blow molding, meaning usually a small former is prepared and that is put in a mold, and then after that air is used for expanding and it fills the shape available. See this. Now if you go to have a look at this nice it has a funny shape. All I can say is the shape is funny. Beyond that, of course in this case it is old. So you will notice here that we have an odd shaped what do you call an entity, and intentionally has been made is not very practical. But then two very important things you will notice about it is, one of them is that we have a very peculiar shape. Across this it is flat, or it is part of a ellipse, a elongated ellipse which has been extruded along this length, and then we have a base which is essentially circular, so that when you see it you will notice that this dimension does not change. So it is easy to hold, and there is also a very peculiar cap that has been added here. See this, it has a funny shape. Now you will notice in this view, no, this dimension does not change, this is narrow, and then you have a funny looking shape here. The idea of the shape is, there is a reason behind that. One of them is easy to pour, okay, easy to hold, easy to pour, and by definition this is a chance for it to slip. To prevent it from slipping, this has been made such that, no, normally when you hold your hand against this and push it, even the unlikely chance of it falls, nothing will happen, and the top has been carefully designed such that it pours easily, and then it can have a cap. So at this point I will go back to the other pictures which I have taken from the, if you see these shampoo bottles, no, you see all of them have that, there is a cap, then you have something here which looks a little like upside down, and then you have something which is a little more symmetrical. So we have so many of these projects which people keep working on all the time. I will close it here at this point. So if you see here, one of the things you notice is that it is not at all a regular shape, and then you see this drinking water bottle. Once upon for a child, now anywhere, no, nobody wants these things. So you have suddenly, you have a requirement for such objects to be created. You have seen this, no? So when you want to create this object, the two parts of it. So I will see if I can make a thing. Kindly if you can put me on to that what you call this other computer here, you will notice that obviously if it is a constant cross section, we start with a what do you call a closed line. I have a peculiar shape here. Can you see it? Now I will see if I can smoothen it. It is very much possible for me to smoothen the object. Alternatively, I can as well start with, I will see if I can what do you call say what best to smoothen this curve. See this, what started here has suddenly become into a slightly different type of a object. Now this is typically, of course, I have a, I mean this is an old thing which has been what you call saved and deleted and all that. You see here now I have a very peculiar what you call object. It is very much possible for me to try to again one more time try to make a free form line. See here, if you see in this view, this is probably what the final object is going to look, and then this is a matter of actually solid modeling. As I said, you should probably now if you see this, I have a interesting object here. See this here, this is how the other one was created. In this case randomly I have picked it, but in reality one has to look at the final object and so on, and here comes the next advantages or disadvantages of rapid prototyping. One of the first thing is, how do you now orient it for printing? In principle there is no problem. However, if you are trying to make shell components like this, the disadvantage being making it thin is a problem. So you end up with a definite what do you call thickness of at least some say 1.5 or 2 millimeters and a huge amount of support material. Our problem is the support material. Do you go ahead and spend so much effort and time on this is our issue to the support problem. And at this point obviously a lot of tips and tricks of the trade are required. So one of the simple way is probably you split it into convenient way in which you can probably lay it up, and then either way you lay it up end up with problems. One of the simple thing is to probably split it across. Is it possible for me? I will see if I can split this object and see what it is. So we have a splitting, a cutting plane. So I take the object for a cutting plane. In this I have a beautiful cut section. Now for me to do the cut section I have to go to the next one and say at best if I can split the whole surface into two parts. If I remove this, now if I go and see the object in the other thing you have seen here, conveniently I have two split objects. The only advantage being in this is, to a certain extent, the undercut and recess has been solved here. But in this case, I mean, because I have no access to the professional package, tomorrow I will try to get it. So, you see here the thickness is not yet solved. Objects which I have shown there, they are very easy for you to construct them here like this. Now, for you to make an advantage, it is possible probably to put supports and all this, and then next comes the most important point of view, saying can we give a texture, can we give a what you call bitmap image which can fit on this. Now, if one goes to the what you call, obviously things are available. So, as just as it is important to maintain the what do you call IP of whoever has created this object, and then the people who create this software, you have to buy a proper commercial license thing. Except for practice, maybe as an individual or an educator you can get a small advantage. And finally, all images that are shown must be, you must get a release about it. If you have some image, it is possible for us to attach the image here. This comes somehow in the, no, not at all in the domain of this. Now, I will see what best I can show you, how best I can build this up. So, you see here, you see here, I have two nice what do you call surfaces which can probably be printed without too much of problem. Seen here. Now comes the our critical thing, saying okay sir, you cut them, you can show them and all that. Now how well it is for you to, I mean, next use all your imagination to see how these things can be joined together. There is some bug here, I am not able to make out what that bug is. So you see here, it is one of these objects can easily be printed. So there was something about that splitting and all this. Now in this condition, it is very much possible for you to build this using rapid prototyping, and later on if we have a proper image, it is possible for us even to transfer things like text onto this. Hope you got my point. So somewhere in the object properties and all that. So building these things are not impossible. I just wanted to show you about it. You have seen this, all the remaining is all what do you call, how actually you play with all these objects and so on. I will try to undo it, go to directly all the way to the beginning. Seen this, probably this is one of the starting points. So I will remove this odd shaped thing. Now I will go back to a more practical this still makes sense. So let us say I start with a circle as before. One of the simple way of it is, you can loft them of different cross sections what you want. Alternatively, if that is a object with a uniform cross section, it is always possible for us to build it out of other see here. So I have this nice snake like object. So I need to make a surface usually by extrusion. Curves to extrude. and then curve. You see here I have my object, it is a little like before, but except that it does not have that funny shape which I was showing you about. Seen this here? Now, not impossible to make these objects. In this case, the cross section was constant, it has just to be extruded. Now, in some cases, especially in technical cases, for example, our things like our lenses and various other things, instead we may end up with having to attach circular portions one to the other. So, next time when you get a chance, my suggestion is go to any of these things, take your mobile and look at the simple thing like the camera which is there in the mobile. Usually it has something like a dozen circular parts. The only thing is it has a axis of rotation or a symmetry. So, in case you have axis of rotation symmetry like this, I will just show you once again in case we have a see here I have something which is a, I mean what I will say, it is a very funny word, put up with me, but which has a peculiar snaky appearance. I will try to rotate it from one end. Oh, still not the direction I was looking for. Now at least it is better. This is what I was looking for. You have seen this. I have a beautiful something here, and then these things can easily be made by rotation. So, in this case I will make an axis of what do you call by rotating this. Yeah, select curves to revolve, start of revolve axis, end of revolve axis, start angle. You see I have what looks a little like a very nice this could be anything. I had used this what I call method earlier to print insulators for high voltage transmission. Advantage is just like we print things in plastic, using this it is also now possible for us to print these things in ceramic, and generally because of their specific these things, they are all symmetrical by an axis of rotation. So, this nice thing, now having this, it is very much possible for you to attach, for example, metal parts. In this case the original curve is still there. Can you see here? This is the original curve. Now, I will see what else I can do with this curve. I will come here. See, I have got a thickness built inside already. This is where you have a slight advantage in compared to any other conventional thing. Imagine you need to make a speaker horn. You have seen this, no? They are horn loaded speakers. At the base you have a driver, and at the thing which comes outside like that, they generally have this symmetry. So, the thing is, things like this will suddenly become easily manageable. You will know what is here. Now when I try to complete this surface, you see what will happen. I join the lot. This has become a closed curve. And now if I try to make an axis of revolution and make a surface, I have a beautiful half object. Seen this? And depending on the type of software you have and so on, it is possible for us to fill this gap. Otherwise, we can leave the gap. If it is very thick, we have to do something about it. It is very thin, it builds by itself. Otherwise, most of the packages, it will give you the advantage of trying to what do you call try to, I will just see if solid oh, it did not do well, there was a problem. So, but the main thing what I wanted to try or show you is saying, if we have a thing like this, printing it and checking it out will be very easy, especially in things like, as I told you, I have given you an example of a high voltage insulator. Sometimes these things will be critical, saying after building, and depending on the material and depending on manufacturer, it is in fact very much possible for us to put these things for test, such that they work without any problem. See this difference between the earlier one and this one is, it already has it comes with a thickness already here. Can you see this? And you can add all the what you call hardware. In this case, usually it will be two ends will be there. One of the ends is, this end probably has one of the live what you call terminals. The other end will have the thing which is anchored to the what you call pole or somewhere, and then the outer part of it is used for carrying the conductors. So, you have the strings they are called here, and you see variable thickness also, you have one thickness there and thickness here. So, that part which is used on to the what you call pole and all probably will be shorter. That part which is used for the stringing may be of a different things. Making these things using rapid prototyping has multiple advantages. One of them is, these profiles and all are determined by the voltages and the corona and the arcing that can take place. When you have this corona arcing and all that, these radiuses and all become very critical. Though I have randomly just like that written this, and it does have an interesting look, in reality a lot of thought goes into it. Similarly, if you see this gap here, things like this are required for one type of diameters of wires, these are required for other purposes like this. So, I would like to what I call thank my colleague who had helped me in all this. Now, you see here miraculously it is also, it appears closed. Probably yes, these are how it is. So, I have a support here, the support is used for fixing it to the what I call pole, and the across this all the stringing takes place across this. Now, the thing is, for us for testing, it is very much possible for us to build these things. First of all, once you have an item, and then you can understand whether it it actually builds easy or not. From here, building any of these things is relatively very easy for us. So, this is what I thought now. These are not the normal simple geometric objects which I wanted to show you earlier. Geometric primitives have known things, but instead this one is it has an axis of rotation. Advantage of axis of rotation and all this is, in fact you can probably go ahead and build it as it is, but by my what you call practice says it's better we build things step by step, see how well we can integrate these things, and then we can pack it. Maybe it is possible for us to fill it with what you call some insulating material. More important, we can paint it. Now you may be asking, is it not what you call real trial and error, and what is it and all that? Not necessarily, because manufacturers themselves, not all manufacturers have these facilities. Instead they design these things and they pass it on to somebody else who manufactures them. So the designer now has full control about all these things, and always having a sample in hand seems to help the manufacturers to understand what it is like this. While it looks just like odd shapes, invariably they end up with having to have you need to fill up with hardware. Seen this, I need to fill up things with this hardware. So there may be a nut inside, or there may be a spark gap. It may be used for other purposes which only the technical people will understand best. I will see whether I can use an edge curve command and then see whether I can close these things. Sometimes it accepts if I am lucky. See here, typically of course there is an error in my construction, so it just sort of went off there. It is very much possible for me to now create an actual 3D object, and then once I have other things, like let us say, as I was telling you earlier, I have to have a spark gap inside. So each and every item what we have here is possible for me to make things. Obviously making a spark gap and all is very easy, because they all come under things like regular what do you call, see just for illustrative purposes I have made it a little bigger than normal. See, this is typically a torus. Seen that, I am sure if you have checked it on the internet, all the high voltage things and all invariably end up with this funny, smooth, highly what do you call circular object. So that optimum, just like we have a problem with a chain saying the weakest link, same thing here in the case of this high voltage equipment. Anywhere the one distance is slightly shorter than the other, the arcing takes place there. It is the very principle of all our lightning catchers and all that. Lightning arresters and all, they will have lot of spikes there. So it is possible for us when we make these things. Now I see here, it seems to miraculously fit here. So I know how these things have to be supported, how I need to what do you call attach things, and how many various types of rings and so on. So unfortunately you cannot make them to full size, because what looks like inches here, 1 inch could be 1 foot. There will be monstrous objects. Typically any of these high voltage insulators and all run into feet. So This is a small one, I just wanted to show you as a sample. So, when it comes to a starting point and so on, no, it is a good place to start with prototypes. So, allow me to what do you call take a break here, and I will continue to the next time, and then maybe so thank you. I just wanted to show you these are not the regular simple geometric primitives when you have no plates and all that. Instead they have curves, they have forms, but axes of symmetry are there. They are slightly different from things like your mouse and all that, which can be done, but not that easy. At least I have no access to a software which I can do. In case you know, as I said, no, three often commonly used things are, you have Dassault's, I think I do not know, Solid Edge or SolidWorks. Then you have Siemens, the other one, again SolidWorks or Solid Edge. Next you have Pro-E. Next you have so many of these things which are available, and if you are a professional, it is very easy for you. I think you should buy it, and occasionally they permit you to use a trial version. Trial versions are generally buggy, and you really can't do much with it. So, buy the proper software, and then if you call the what do you call people suppliers, no, they will come and demonstrate all your capabilities. So, if you want to, if you can understand what is it you want to do, a good solid modeling software is required, and the ones that are freely available on the internet is okay. It's, I mean, it's as a novelty you can try, but my suggestion is buy it. If you are an educator, you can also get an educator's discount. Usually you can get very good software for around maybe $300 to $500. So, best of luck. I will continue in the next session and try to show you how even machining objects, in this case we wanted to make a heat exchanger cold plate meant for liquid cooling of high power electronics. We have made that, so the model is ready, but I have no access to it right now. I will try to download the model and then show you the video also next class. So, thank you, that will be it.